Hi guys, welcome to our video lesson on polar and non-polar bonds. So let's get straight into it. The key terms that we're going to look at today include electronegativity. The definition for electronegativity is the ability of an atom to attract electrons. Partial charge is when an atom has a slight negative or positive charge. So it's not a whole charge, as the electrons are not completely lost or gained. A polar bond is a covalent bond where the electrons are not shared equally, therefore the bond has a partial charge at each end. A nonpolar bond is a covalent bond where the electrons are shared equally, therefore the bond has no charge. The last word is dipole. And a dipole is when a bond or a molecule has two oppositely charged ends. At this point, I'd like to ask you to pause the video and record those definitions in your notes document. So, a polar bond is a difference in electronegativity between two different non-metal atoms. So here we've got two different non-metal atoms. We've got a hydrogen atom and we have a chlorine atom in a covalent compound, and that results in electron pairs not being shared equally. Now this is a covalent compound because we've got two covalent atoms and we have a covalent bond, and that's represented here. So with the chlorine we have the valence electrons represented as blue crosses. So chlorine has 1, 2, 3, 4, 5, 6, 7 valence electrons, and hydrogen has 1 valence electron, which is represented obviously by the red circle. Now in order to get full valence shells, chlorine and hydrogen are going to share 1 electron each. So they're going to share these two in the middle here. So now chlorine has 8 valence electrons, which, going by the octet rule, is the perfect number, and hydrogen has 2 valence electrons, which fills its valence shell. So they're both nice and stable, and we've got our covalent bond in the middle here. At this point, I'd just like to ask you to pause the video again so you can write this paragraph down in your notes. So just a reminder with electronegativity. So electronegativity is the ability of an atom to attract electrons. Now with the periodic table, the trend is electronegativity increases as you go from the left to the right of the periodic table. So if we look at period 2 as an example, lithium, beryllium going across, boron, carbon, nitrogen, oxygen and fluorine, electronegativity is going to increase as you go across. So out of all of those, fluorine would be the most electronegative atom. So fluorine has the greatest ability to attract electrons towards it. Electronegativity decreases as you move down the periodic table. So if we look at group 1, hydrogen, lithium, sodium, potassium, rubidium, electronegativity would decrease there. So all the way down the bottom, francium, that has the lowest electronegativity out of all of the elements. So in the same example as we've gone through previously, we've got our HCl again, just a slightly different diagram this time. So in this circumstance, the bonding electrons will be pulled toward the more electronegative atom. So as per the electronegativity trend that we established before, chlorine is more electronegative than hydrogen. So the shared electrons, these two here, are going to be drawn closer to the chlorine atom. So it's an uneven sharing of electrons. So chlorine will have a greater share of those electrons than hydrogen will. A covalent bond in which there is an unequal attraction for the shared electrons is called a polar covalent bond. So the covalent bond that exists between hydrogen and chlorine is a polar bond. Now here the covalent bond is being represented by a line, so this is our valence structure. So the same thing as before with the electron dots, it's just a different way to represent it. Now these symbols here are a little bit obviously new. So this symbol is the Greek symbol and it's called delta. You may have seen the delta in physics as a triangle, but this is a lowercase delta, so it looks like this. This indicates a partial charge. So it's not as strong as a full ionic charge, it's a weaker partial charge. And this comes about because the electrons are being shared unevenly. So they're drawn more towards the chlorine atom, which means you get a partial negative charge because electrons are negative. And on the opposite end, we have a partial positive charge on a hydrogen. At this point, I'd like to ask you to pause the video again so you can record this paragraph in your notes. So here we have a few questions based on electronegativity. The table at the top has a few different elements with numbers to represent electronegativity. So the electronegativity of fluorine is 4.0, and then you've got other numbers representing electronegativity strengths or values. So the numbers are arbitrary, there's no units associated with that. So this question here is saying to identify the atom in each pair that would have the largest share of the bonding electrons. So finding the most electronegative atom out of the two. The next question is asking which would be the most polar bond, so the greatest difference in electronegativity, and which would be the least polar bond. I'll ask you to pause the video again and record the answers to these questions in your exercise books. So we've discussed polar bonds. The next part is a non-polar bond. So it's the opposite, obviously. Covalent bonds that are formed between atoms of equal electronegativity are said to be non-polar. So two examples. We've got a molecule of oxygen. So a molecule of oxygen is two oxygen atoms, and you have a double covalent bond formed between those two. That's due to the covalency of oxygen being 2. So because both atoms are the same, they're going to have the same electronegativity. So the electrons that are shared in that covalent bond are going to be shared equally. Another example is a molecule of nitrogen. You've got a nice strong triple bond in here. So each bond out of the triple bond is 2 electrons being shared. And they're going to be shared equally because both atoms are the same. They're both nitrogens, so they both have the same affinity for electrons. So each of those bonds are going to be non-polar bonds. So just to remember, polar bond is an uneven sharing of electrons, and a non-polar bond is an even sharing of electrons. The way to remember that: polar bears are greedy. Look how greedy that polar bear is, just drinking that coffee. He's got 3 more to go. He's not sharing that with anyone. Guys, I really hope you learned something from this video, and I will see you in class.